Now see, we discussed about the recursion. So just I will going to take the recursion program. Okay, so I wrote the program, right? Same program I will take it. Just see this program. If you have any doubts, you can ask me. Okay, na? Fine. Now see, everybody observe here. So morning we wrote factorial, fact, parameter. This is int n. Okay, again open the body. Okay, if n is less than or equal to 1, what it will return finally? Return 1. Okay, again after that else part, I will write else part. Here it will going to return what is that? I told you already, n into factorial of this. Here observe here, n into factorial of n minus 1. So when you do this, okay, when you do this, what you will going to get it? You will going to get the recursion program. So just I will going to consider this one as an example one. Please observe here. So I will going to consider this one as an example one. Now, please everybody be careful here. Please everybody be careful here. This is, we know that very clearly, it is a recursion program. We know this program. Yes or no? This program is a recursion program. But what we have to do for this? So by using this, what we can do? We can write one thing. What is that? Recursion relations for value. So first one I will going to say you people what we can do by using this program. Please understand everybody. By using this program, we can write, please observe here, we can write what is that? Recurrence relation. Okay, recurrence relation for whom value. Clear? Be careful, these things are very, very important. So what we can do with this program, we can write recurrence relations for value. For value, we will going to write a recurrence relation. Sir, how to write this? Okay, please understand how to write this. Very simple. What we have to do, it is a mathematical representation. Recurrence relation for value is nothing but it is a mathematical representation. How to write it? Very simple. For example, I will going to assume, everybody please observe here, I will going to assume fact. Here we have fact integer n. Can I say like this? Fact integer, can I say this like this? T of n. Can I say like this? T of n. If you are not able to understand, later you will want to understand. If you are not able to understand right now, you will going to understand. For that, it's okay. I will not going to confuse you people. So that what I will going to do, I will going to take f of n, function n, f of n. This is what exactly, this is a function, right? Completely, this is a function. That's why I am taking t of n, but it's okay. Right now, I will going to take f of n only. F of n, now see everybody. F of n, sorry. F of n that is equal to, please observe here, f of n that is equal to, now what I will going to do, please observe this line everybody, please observe this line. Okay, if n value is less than or equal to 1, what it will going to do, it will going to return 1. Yes or not? Nothing but if you get the n value is equal to 1, less than 1 equal to 1, nothing but what? It is true, this condition is true, then it will going to return 1. So that's why what happens here, anyway it will going to return 1 if this condition satisfies. Yes or not? Anyway that will going to return if this condition, what is that condition? N is less than or equal to 1. If that satisfies, you will going to get, how to write this one, sir? Very simple. 1. It will going to return 1. Everybody see here? It will going to return 1 when if n is less than or equal to 1. So this is exactly you have to write it. So writing recurrence relation for value is nothing but exactly you have to copy whatever the things which are available in this particular statement, which is available in the function. Fact is a function. which is in this function you can able to see this is one statement, this is one statement, this is one statement, like that statement exactly you have to copy as a mathematical way in a mathematical representation. That is what we call it as recurrence relations for value. I am not writing for time right now, later I will write, wait, later I will write, don't worry, later I will write. Okay now, until that please wait, until that please wait. Now I told you you have to copy everything, yes or not? See, for example, what we have right now, if else, if it is not true, nothing but what, if n value is equal to 10, 10 is less than or equal to 1, no, then it will go to the else part. Again it will going to take 10 into factorial of 10 minus 1, like that it will going to do. Again finally you will going to this answer, whatever the return, that will be go to the main function. So it will go to the, it will give the answer to the main function. Now what I will going to do, oh, you will going to write in a mathematical way. Just you have to take this one. What is that exactly? If n is greater than 1, please understand, if n value is greater than 1, it will go to the else part. That's it. If n value is greater than 1, everybody observe here. If n value, suppose 6 is greater than 1 or not? Yes or not? It is 6 is less than or equal to 1. Actually, it's false. That's the reason why it will go to the else part. So that's why you please write like this. Everybody, write please like this. You please write like this. What we have to do? N into. Please observe here. N into. Okay. N into factorial of nothing but factorial of n minus 1 is there. That's why I taken f of n. Yes or not? Fact in 10. So this one I consider as a function, completely function. This function inside that there is a recursion. So I will going to say f of, see, observe here, f of, okay, n minus 1. Okay, when you will going to get this one, please observe here, when you will going to get this one, n into f of n minus 1, when you will going to get it, if n value is greater than 1, this relation we will call it as, what is that? This relation we will call it as recurrence relation for value. Okay now, guys? Okay, okay, everybody understood? This relation we will call it as recurrence relation for value. You have to write a recurrence relation for value, and you have to write a recurrence relation for time. Okay, I will going to show you that one also. Please be waited, please be waited. Okay, so there are, you can able to see there are two parts are there. One part is this, again one more part is this. Yes or not? There are two parts are there. As it is, you have to copy. Okay, as it is, what is that? If n value less than or equal to 1, what you will going to return? That is 1. Here it is there. If n value is less than or equal to 1, it is returning 1. That is the reason why if n is less than or equal to 1, what we will going to do? We will going to get the value 1. Again, come to this line, come to this statement. Again here, return n into factorial of n minus 1. When it will going to execute? Please, when you will going to come here? Please observe here. When you will going to come here? Basically, if n value is greater than 1, then only you will come to the else part, right? That is the reason why. If n value is greater than 1, you will come here, n into factorial of n minus 1, nothing but f of n minus 1. So I will say this one. Let, okay, f of n, please understand, f of n is nothing but function. F of n, that is equal to fact n. That's it. Okay. So whatever the thing we are writing here, see this thing, whatever the things I written here, I wrote here, everything is belongs to what is the recurrence relations for value. Okay. So this is really easy to write. Yes or not? This is really easy to write. Nothing is there. Very easy. So this representation, we will call it as mathematical represent. That is what I told you. Algorithms, studying algorithm is nothing but, you should know the mathematics also. So that is one thing you have to understand. Again, what you will go, sir, why you are writing all this thing? To get the value, So what is the value you will going to get it? N value, n factorial, to get the value. Okay. That is the reason why we have to write the recurrence relation for value. Everybody got it? Everybody got it? Please let me know. So just mathematically, whatever the things I have written here, please, whatever the things I have written here, that thing is related to what? Mathematical. Okay, mathematical. Okay, now. So mathematically I have written this one, this complete one. What is this? Recurrence recurrence relation for value. Okay, now everybody clear? Please let me know. Everyone clear? Now see the important one here. Write a recurrence relation for time. Okay, write a recurrence for time. Please observe here. So what are we going to do here? Just everybody observe. Okay. Now see here. Recurrence relation for time. Recurrence relation for time. Okay, now. So what we are doing now? How to write a recurrence relation for time? We understood how to write a recurrence relation for what? Value. We understood this one, how to write a recurrence relation for value. Nothing but exactly whatever the program is there, just copy that program into mathematical way. This is what exactly I told you. So why we are getting one? Because of these things already explained. Okay, just go through once again, no problem. Okay, again let's here everybody please observe here please observe everybody. You have to observe right now, you have to observe very clearly. Let us, okay, let us take or assume, let us take or assume T of n. Please understand T of n. Okay, time complexity of a function. N is nothing but I told you it's a function on inputs. T of n that is equal to, please observe, T of n is equal to, that is equal to time complexity. Okay. I will going to take time complexity of what? Of factorial n, of factorial n. So what is that? For whom we are doing this one? For whom we are doing this one? For time. Okay, for time. Understood everyone? Please be careful here. Everybody, you should be very careful. So what we are doing the recurrence relation for time here. Okay, for time we are writing the recurrence relation. Let us understand this one. Why I am writing Tn is nothing but factorial in Tn. We are taking, this is a function or not? That is the reason why I taken Tn as a function here. Please understand Tn as a function here. No need to get confused here. Please understand Tn I have taken as a function, nothing else. Function anta ತಗೊಂತಾ ಇದೀನಿ. That's it, nothing else. Now write the recurrence relation for time. See now Tn, everybody observe here. Tn, okay, Tn that is equal to Tn that is equal to, now please observe here. So what we are doing basically, please observe. 1 minute now. Please mute it. Hey, Abhishek, unmute. Okay. Now understand here. So how to write a recurrence relation for time? Nothing but time complexity I'm talking about here. Okay. So what is that? Time complexity for factorial of n. So whatever the value n is, nothing but it's an input we are taking. Okay. So time complexity for this one. Now see here how to write this one. So basically when you see this one, if f of n, see here, if n is less than or equal to 1, please understand, if n is less than or equal to 1, what it is written? What it is returning? It is returning 1. 1 is nothing but what is that? Basically it's a constant. That's the reason why what I will going to do, I will write here big O of 1. Okay, I will write here big O of 1. When you will going to get 1? If please understand, n is okay less than or equal to 1. That's it, nothing else. Okay, now see here, I told you very clearly. Please understand. Now it's very interesting. Now it is very interesting. Please observe here. I told you very clearly. When I say factorial of int n, when I say this one as a t of n, when I say this one as a t of n, when I'm taking t of n as a factorial of n, yes or not? When I'm taking factorial of n, for this factorial of n, what I'm taking as a t of n. Yes or not? This function I'm taking as a t of n. And see here, factorial of n minus 1. Please observe here, factorial of n minus 1 for fact. Okay, understand here, fact of n. So what I am taking, I am taking t of n. I will going to take t of n. Okay, but what we have right now here, factorial of n minus 1. Please observe here, factorial of n minus 1 is there. Can I take like this, factorial of n minus 1? For this one, can I take like this, t of n minus 1? Is it true? Can I take like this? Yeah, absolutely, we can able to take it. So that is what exactly I'm doing here. What is that exactly? So when you do this, when you go to the else part, what you are getting? Factorial n into factorial of n minus 1, nothing but what? I will go on only function. That is the reason why t of, please observe here everyone, t of, okay, n minus 1. Okay, t of n minus 1. Clear everyone? T of n minus 1. Again, I told you to everyone, I explained everyone. What do you mean by time complexity? Time complexity is nothing but loops. Time complexity is nothing but loops. Have you any loop is there here? For loop? No. Have you any while loop is there here? No. Have you any while loop is there here? No. Have you any for loop is there? When there is a no loop, what is that? It's a constant. When there is a no loop, it's a constant. When you are getting this one, factorial of t of n minus 1, when you are getting t of n minus 1, if n is greater than 1, so this one we will call it as a time complexity for recurrence relation for time. Okay, understand? Recurrence relation for this one we will call it as recurrence relation for 1. Anybody have doubts how we got 0 of 1? Nothing but it's a constant. That is the reason why we are getting big O of 1 here. Okay, so when you are getting that big O of 1, because the reason is if n is less than or equal to 1, that is the reason why we are getting. Again, if n is greater than or equal to greater than 1, suppose example, if n is greater than 1, what happens? I have to do this. This is our recursion, not n. Yes or not? Please understand. Sir, why you are not taking n? You can ask me. Why I am not taking n? Because this is not a recursion. What we are doing? Recursion is only this. Recursion is only this. That's why I'm taking that. Correct? Recursion is only that. Okay, I don't want to take n, that's why. So that's why t of n minus 1, again no loops are available in this particular function. Yes or no? No loops are available in this particular function. That's why I taken as constant. I taken as constant. Again, so further you can able to do, but we don't want to do, but still I will want to tell you the final time complexity of this particular one is big O of n. Already I given the example, big O of n. Okay. Understood everyone? Everybody understood? I think everyone understood. Sir, when you will going to get the n square? You can ask me, sir, when you will go, when we can able to get the n square, when we can able to get the n cube, all those things. Suppose I told you very clearly, time complexity is nothing but loops. If you have a for loop, inside one more for loop is nothing but that is n square. Again, inside one more for loop is there, 3 for loops is there, nothing but it's a n cube. So we have, do you think we have any for loop or while loop here? Nothing is there. So that is the reason why I taken plus c. It's a constant. Okay. Loop not there. Please understand. If the loop is not there. Okay. If loop is not there. If loop is not there. Then I will say it's a constant. Then it's a constant. Okay, that's it. This is what exactly you have to do. Okay, anything you take, add of 2 numbers, again subtract of 2 numbers, multiplication of 2 numbers, whatever it may be. Okay, so what we are doing here exactly, we are doing recurrence relation. Please observe here, this one, recurrence relation for time, we are doing for time. So this is for recurrence relation for time. Please understand, recurrence relation for time. This is recurrence relation for value. So this is a very important. Actually, further we will going to do one more problem about this. Again, in so many problems we will going to solve you. I don't want to push you with the difficult one. First, we will going to see simple one. After that, we will going to go for difficult one. Okay, let's see one more example. Everyone. Okay, before that, let me ask you this one. So when we have a program like this, okay, a of n is a function. Again, it will going to return n into n. Again, this will going to execute only one time. Okay, so if it is executing one time is nothing but what is the time complexity? That is constant. Yes or no? That is constant. Yes or no? So that is the reason why I wrote big O of 1. That is the reason why I wrote big O of 1. Nothing but what it says that there is no loops and time constant means loops. Actually, we said very clearly. Is there any loops in this? Is there any loops? No loops. No loops. Okay, that's why time constant here. Okay, that's why I written big O of 1. Okay, clear. I think everybody clear. So if you solve the recurrence relation, you will going to get the time complexity. Please observe. If you solve the recurrence relation, you will going to get the time complexity. That is what exactly I did here. After solving all these things, okay, recurrence relations for time. When you solve this one, what you will going to get it? You will going to get the time complexity that is big O of n. This is what exactly we will going to get it finally. So that's why be careful. Okay. So very important programs. Actually, these are all very important programs. Fine. So again, you can ask me, sir, I understood everything, sir. Whatever the things you said, I understood very clearly, sir. But sir, I have a problem, sir. If any problem, any program given means what you have to do. Okay, if any program given, how to find the recurrence relation, okay, how to find the time, all those things. Or if you got a program, first think like that, you got a program. Okay. First, what you have to do, you have to write a recurrence relation for what is that? Okay, first you have to write a recurrence for value. Okay, after that, you write a recurrence relation for time. That's it. Automatically, you will going to get it. When you write a recurrence relation for time, you will going to get the time complexity here. Okay, na? Okay. Okay. Okay, fine. I think everybody got this. Okay, let's move. One more example, I will take it. One more example. Please go. One more example, I will going to take it. Okay, na? Fine. Let's take example number 2. Example number 2. Okay, now take this. Let's take an example. A of n. A of n. I will solve. Don't worry. I will solve. If n is less than or equal to 1. Okay, what it will return? Please observe here. Return n square plus n plus 10. Please observe. So if you go to the previous problem, see here, if you go to the previous problem, not here, here. So what it is returning, if n is less than or equal to 1, return 1 it is returning. But here you see, here you observe here, if n is less than or equal to 1, what you are getting? Basically, n square plus n plus 1 you are getting. Yes or no? So please be careful with this. So this one, be careful. Fine. Now, after that, else, go to the else part. Go to the else part here. Now, return, okay, 10 into, please be careful, 10 into a of n, function a of n, okay, a of n, what is that? N by 2, okay, n by 2 plus, okay, plus n square plus n cube, like this. Okay, it will going to return this finally. Getting everyone? Now close the function. That's it. This is my function actually. So what is my function? My function is a of n. Yes or not? My function is a of n. In that you can able to find if n is less than or equal to 1, what it will going to return? It will going to return n square plus n plus 10. Again, else part, if it is not true, okay, if it is not true, nothing but false, it will go to the else part. Again, it will going to execute this particular statement. That is what? Return 10 into a of n by 2 plus n square plus n square plus n cube. Now, first what we have to do, I told you, first what we have to do, we have to write, please understand, we have to write recurrence relation for value. Yes or no? Okay, first we have to write the recurrence relation for value. Okay. Now, how to write? Already explained about this one. How to write? Already explained. What we have to do? function, you can take this a of n function, I can take assume. Okay, please understand, a of n is a function, yes or not? I can take like this t of n. Okay, function a of n is nothing but t of n, I will going to take. Okay, assume a of n is equal to t of n, I will going to write here assume a of n is equal to t of n. Okay now, fine. Okay, fine. Now what I will going to do, I will going to write a recurrence relation for value. How to write t of n? Everybody please observe here, t of n is a t of n that is equal to, okay, that is equal to, so I told you as it is, this is a mathematical represent, I told you, right? It's a mathematical representation. Mathematically we are representing this one, mathematically we are representing nothing but what, if n value is less than or equal to 1. What is that? If n value is, if, okay, n value is less than or equal to 1, so what it will going to return, exactly you write whatever the things is there in this statement, exactly same thing you have to write it. So what you will going to get it, n square plus n plus 10, that's it. Okay, so this one, after that, if n value is, please understand here, if n value is greater than 1, suppose n value is 10, 10 is less than or equal to 1, no. 9 is less than or equal to 1, no. 8 is less than or equal to 1, no, like that. Okay, here if n value, please understand, if n value greater than 1, then only we can go to the else part, right? 10 means I will go to the else part, 9 means I will go to the else part. Okay, like that I will go, right? 8 5 4 3 2 1. Okay, 1 means 1 less than or equal to 1, then it will going to execute, it will going to return this. If n value is not equal to 1, where it will go? It will go to the recursion here. This is recursion here. Please understand, this is recursion, same function I am calling here again and again, again and again. That is what I said very clearly about the recursion, nothing else. Yes or not? Nothing else. Okay, fine. So that is the reason why what I will going to do, as it is, please, as it is, you have to write it. What is that? 10 into a of, okay, n by 2, correct? A of n by 2 plus n square plus n cube. That's it. This is how you will want to write a recurrence relation for value. Okay, recurrence relation for value. That's it. Very simple. Easy, right? It's very easy, right? Now everybody please observe here. Now everyone please observe here. So what we're going to do now, please, I will going to write a recurrence relation for time now. Okay, I will going to write a recurrence relation for time, that is time complexity. So we will going to write that one, recurrence relation for time complexity. Okay, now so we will see this. Now let us assume, please everybody, let us assume here. Okay, everyone, let us assume. Okay, let us assume t of n, nothing but this one. Okay, function already we have taken, a of n is equal to t of n. Assume, you please assume t of n that is equal to, what is that, a of n, whatever the value a of n is there, function, that one I am taking as a t of n. Okay, so for what? Time complexity. Please observe, don't neglect. Okay, so already I told you very clearly, time complexity is nothing but what? It's all about loops. Now see here, any loops is there in this? Nothing. Any loops is there in this? Nothing. Yes or not? For loop is also not there. While loop also it's not there. Don't worry. Now see here, if, see here, that is what exactly I'm writing. Tn. Please observe here, Tn that is equal to, okay, Tn that is equal to, what is this? Okay, fine. So Tn that is equal to, now you people observe here. So what is this basically? If n value is less than or equal to 1, okay, everybody observe here, if n value is less than or equal to 1, what happens? It will going to return this one, n square plus n plus 10. Okay, Basically this one, when you see this one, what happens, it will going to execute only one time, right? This statement will going to execute how many times? Actually it's a one time. Is there any extra it will going to execute? Nothing, but a while loop is not there, as well as for loop also is not there. It indicates very clearly this line executes only one time, nothing but it will going to return the value one time only. Suppose you take n value is equal to 5, 5 plus again 5 plus again 5 square plus 5 plus 10, anyway one value you will going to get it. So that is the reason why what I will going to do, it executes only one times. That's why big O of 1. Okay, big O of 1 when if n is less than or equal to 1. If n is less than or equal to 1, fine. Okay, then if you are able to understand this one, please observe. If you are able to understand this one, sir, why you have taken big O of 1? Reason is that already I explained in previous program also. Okay, so when you will going to get the big O of 1, because the reason is n is less than or equal to 1, that time only you will going to get this one. Fine. Now come back here, please see here this one. Okay, now observe this one, please everybody observe this one. If n value is greater than 1, then only we go to the else part. Here also, do you find any for loop? No. Do you find any while loop? No, not at all. And see here, in this function, everybody observe here, in this, okay, in this statement, please observe here. Where is the recursion? Here. Where is the recursion? It's here. Is that not? Where is the recursion? Is here. Already I am taking, what is that? Already I am assumed very clearly T of n is equal to A of n. Yes or not? A of n is equal to, I am assuming as a T of n. Now, A of n by 2, can I say that T of n by 2? Can I take T of n by 2 like that? Absolutely, I can take it. That's the reason why T of n by 2. Okay, is there any loops? No loops, no loops. Please understand, no loops here, no loops. That is the reason why plus C. That also I said. Plus C. That also I said. Okay, why I am taking C? Because no loops is there, extra loops is not there. Otherwise I would have taken something else. Yes or not? So when you are going to get this one, T of n by 2, when if n is greater than 1. Yes or not? If n is greater than 1, then only you will go here. Yes or not? Otherwise you will not go here. Yes or not? So that is the reason why every time for C, this is constant, because no loops, no loops. Okay, now if you are able to understand this one, if you are able to understand recurrence relation for what is the final you will going to get it in this. What is the final you will going to get it? Finally, what I will going to do it? Already I solved one problem on t by 2, sorry, n by 2. Already I solved one problem. If you solve this one, you will going to get the value. Please observe here, you will going to get the value big O of log n. This is the value you will going to get it. This is the time complexity you will going to get it. Already I solved. Yes or not? Already I solved. So you will going to get log n, big O of log n. Understood everyone? Are you clear with this? Everybody clear? Hello. Hello.